Okay, so we broke chapter 5 up into two parts. So here's the beginning of part 2. Part 1 was all graphing, and now we're looking at solving quadratic equations, and we're also going to talk about imaginary numbers, but not in this section. So we want to factor these so that we can figure out what the x-intercepts of the parabola would be. Okay, that's the whole purpose of doing these. So if we're going to solve these, the only difference from last chapter, chapter 4, our factoring chapter, and these is there's an equal sign involved. Okay, before we were just factoring and then we would just leave it there. But now we have an equals 0 on the end, which allows us to actually get answers, like number answers instead of factors. All right, so looking at the first one and all of these, what is our first step on every single time we factor something? Can we take anything out? Can we take anything out of those? Yes, on the first one. We can take an x out of both of them, which leaves us with x minus 9. Okay, so this is the factored form of this problem. Okay, once we get it to the factored form, we're going to take each of the factors and set them equal to 0. So we have x equals 0, and we have x minus 9 equals 0. Okay. This second one we have to solve for x. The first one already is, but this second one we would add 9 to both sides. So we're always going to get two answers. Okay? If we were to graph the parabola, the x-intercepts would be at 0 and 9. Okay, that's what we just found. You don't have to graph it. I'm just saying this is the reason why we would find these numbers. Okay, we have 3 terms on this one, so what's our first step? First of all, can we take anything out? No, so now we will factor it by doing what? When you have 3 terms, we draw an x, yes. Okay, so we draw our x. What number goes on top? Negative 28, because we take a times c, and a is 1, and c is negative 28. And then on the bottom? Negative 3. Now remember, we're trying to find two numbers that multiply to this and add to this. Okay. Now, do we have to do the window step? No. How come? Because there's no number in front of the x squared. Okay, so these actually go in the parentheses. X minus 7, x plus 4 equals 0. Now, like I said before on the last one, once we get it factored, we set each of the factors equal to 0 and solve. So we've got x minus 7 equals 0, and we have x plus 4 equals 0, which means our two answers are what? This one would be 7 because we have to add 7 to both sides. This one would be negative 4. And we subtract 4 on both sides. Okay, what should we do on the next one? We want to move the 72 first. Okay, so we're going to add that to both sides. Okay. Now we can take the 2 out, because I heard somebody say that. Divide everything by 2. Now we have 3 terms here in the parentheses, so we can do the same thing we did on the previous one, right? Okay, so we draw our x. We take a times c, which is 1 times 36. Then we have b on the bottom. Two numbers that multiply to positive 36 and add to negative 12.
Negative 6 times negative 6.
Mm-hmm. Do we need the window step? Nope, because there's not a number right here in front of the x squared. Okay, so that means we've got this as our factored answer.
Don't you need the 2 out front too?
We do need the 2 up front, thank you. And now we're going to set each of our factors equal to 0. We're not going to set 2 equal to 0 because 2 equals 0 isn't true. 2 doesn't equal 0. 2 equals 2. Okay, so we've got x minus 6 equals 0, and the other one is the same. So on this one, we only get one answer, which is positive 6. 2, if we write 2 equals 0, that's not true. So we don't write that. If there's an x out there, we do write that. Okay. Questions? So the only thing that's new is this last step where you set it equal to 0 and solve. Okay, and factoring is not going away even after this chapter, so we need to keep practicing this and not get discouraged if it's still a struggle for you. We need to buckle down and figure it out. So we're going to practice a couple more. Okay, but we're going to go the opposite direction. Okay, so these right here are the answers. So if we look back here, what I've given you are numbers like this. Okay, the 2 answers that go along with the problem. So if we're looking here, we know that x equals negative 8 and x equals 5. That's how you're going to start this problem. So if we're working exactly backwards, now we want to get these to both be equal to 0. So on this one, we would add 8. This one we would subtract 5. So x plus 8 equals 0, and x minus 5 equals 0. What would be the next step if we're working perfectly backwards?
X plus 8, in parentheses, other parentheses, x minus 5, right parentheses equals 0.
Now all we have to do is multiply these two things. Okay, easiest way is to just place them with a window here, x plus 8, x minus 5, and now we just multiply each of them. So if we've got x times x, x squared, what's this one? 8x, this one, negative 5x, and negative 40. Okay, so these 4 terms right here, these are like terms, so we can combine those to be what? What's negative 5x and 8x? 3x. Okay, so then right here in the diagonal, that's your answer. X squared plus 3x minus 40 equals 0. Okay, when there's only one number, remember that means that there's 2 of them. We just don't write the other one. Okay, so if we get these equal to 0, we're going to slide the 6's over, so we're subtracting them on both sides. So minus 6 means we have x minus 6 equals 0, x minus 6 equals 0. We'll throw them in parentheses and multiply them. And we can do a window for that. So if we take x times x, got x squared minus 6x minus 6x, and then positive 36. So what number is in the middle when we combine like terms there? Negative 12x. So right here is your answer.
Let's do this.
And we've got the equation it started out as. Now the last 2 are a little bit different, so I definitely want to go through these examples. We're going to start them the same way, set them both equal to 0, or sorry, x equals the number. Now we want them equal to 0, so we have to subtract this 9 over here. But this one doesn't change at all, so these are where we're at right here. So how would we write this as an equation? Parenthesis x minus 9. Okay, because we've got this factor and then we have this factor, so we just multiply them. And do we need a window for this one? No, you can just distribute the x, right? So if we distribute the x, we have x squared minus 9x. That's what it started out as. All right, the fraction one. I'm putting this on the test. It won't be 2/3 as a fraction, but you will have one of these on the test. Okay, which is coming up a couple days from now. We're going to start it the same way. X equals 5, x equals 2/3. Now we're trying to get 0 over on the one side. So this one we know how to do. We can just move the 5 over. X minus 5 equals 0. So that's one of them. But we want to somehow get rid of this fraction so that we don't have a fraction at all. So what could we do to both sides so that we could get 0 over on the right eventually?
1 by 3.
Yeah, let's multiply by 3 first. Don't just subtract 2/3. You're not going to get the right answer, the answer that I want. So we've got 3x equals what over here now? 2, because the 3's canceled out. Now what do we do? Subtract 2. So 3x minus 2 equals 0 is our other factor. So we've got x minus 5 and 3x minus 2. And now we just need to multiply them. So we've got x minus 5, 3x minus 2. So we've got 3x squared here. And 10, which is negative 17x in the middle. So here's our answer right here, which is 3x squared minus 17x plus 10 equals 0. So we're going both directions on the homework. Okay, we have, when you have the given factors, finding out what it started out as, and then what we did over here, which was starting with the equation and getting the two solutions. Questions?
All right, go to. About a normal size homework today.